Okay, continue lesson 2 on topic of EMF E and internal resistance R. Okay, let's say we want to carry out one experiment to show the relationship between reading of voltmeter and current. So these are the setup of the apparatus. So we have a dry cell. So I put the label here, internal resistance, small r. So the whole thing, the green bracket here represent the dry cell, meaning the dry cell with internal resistance, small r. The switch, ammeter to record the current, a wire or conductor with resistance R, a rheostat to adjust current because we want to get 5 set of data, and then a voltmeter connect across the conductor R. The voltmeter also can be conducted across the battery, so the result will be the same. Alright, before in lesson 1 we have discussed EMF equals to V plus I small r, and the V equals I times capital R, which is the external resistance. So we switch on, the switch is on, meaning we close the switch. Close the switch means the switch is on. So what we do, use rheostat, adjust the reading of ammeter to 0.1 ampere. Then we record the reading of V. Right? Before we have discussed that the reading of the voltmeter is equivalent to the potential difference across resistor in external circuit. So we get V equals E minus I small r. So when there is I flow in the circuit, meaning the value of I is equals to E minus I small r. There will be a voltage loss, meaning the reading of the voltmeter becomes smaller than E. As you can see, when the value of I increases, meaning E will minus larger value, thus the value of V decreases. So meaning, let's say we have 5 set of data. We have 5 set of data. So the first one 0.1 ampere. So we record the reading V and put in the table of data. Then use rheostat to adjust the reading of the ammeter until we get 5 set of data. So you can repeat to 0.2 ampere, 0.3 ampere, 0.4 ampere and 0.5 ampere. Then what we do, we plot a graph of V against I. So the first one, let's say 0.1 is here. So we have the value is quite high, so it should be here. So we put the first point there. Then continue, transfer all the 5 points. Let's say we have, okay, the arrangement of the point is like that. Okay, now we draw the lines to represent the graph. Okay, use ruler to draw, so we get a straight line showing that V decreases linearly with I. So once we have this graph, what we can get from the graph? Okay, last time we discussed that when I equals to 0, so there's no part here becomes 0, so meaning the reading of voltmeter equals to EMF. So when I equals to 0, meaning intercept here. So we extend the line, pass through V axis. So at this point, I equals to 0, meaning this value here represent EMF. So what we can say that intercept is equivalent to, intercept at V axis equivalent to EMF. Okay, and then draw triangle, calculate the gradient of the graph. Okay, let's say we draw from here this triangle, okay, and the value here is V and the value here is I. So we have the gradient negative, negative value, E minus V divided by I. Okay, so E minus V divided by I coming from this formula. If you rearrange the formula, you will get R equivalent to V, sorry, R equivalent to E minus V divided by I. Okay, so meaning this one, there's a relationship between the gradient and internal resistance. Okay, so meaning the gradient actually equivalent to negative R. Okay, or we can say R equals negative gradient. Okay, so from the graph we can determine EMF and internal resistance. Okay, now we can try some of the question regarding this part.